Okay, hello everyone and welcome. Thank you for being here. I'm really excited about this session, the best paper session, and I don't want to steal any time really from the two presenters. So without further ado, here's Hans Gaebler. He's presenting the EMO Best Paper Award, a simple statistically robust test of discrimination. Thank you, Hans.
Yeah. Do I need this? Can everybody hear me? Okay, thank you everyone. My name is Hans Gaebler. I'm a statistics PhD student at Harvard University, and it's a huge honor to be here and to present to all of you. I'm going to talk a little bit today about some joint work with my advisor, Sharad Goel. See if I can figure this out. Okay, so let's imagine that you are a statistically savvy financial auditor who happens to bank at the local Wells Fargo. And let's imagine, completely hypothetically, of course, this is a fake bank, that Wells Fargo has gotten a bit of a bad rap for, I don't know, fraudulently opening accounts in people's names, charging people for auto insurance that they didn't sign up for, and all sorts of stuff like that. And so you hear some rumors about the possibility of discriminatory lending practices. So you decide to investigate. So a very natural first thing to do is to try to dig up some data on who is getting approved for loans. So let's say that you find that 91% of applicants from the majority group are getting approved for loans, whereas 87% of applicants from the minority group are getting approved for loans. And one thing that I should mention from the outset is that for simplicity, I'm going to talk about sort of a majority and a minority group throughout the whole talk. By that, I don't mean that the majority group is literally larger. I just mean that if you were going to guess, if sort of you had to guess that which one of these groups was getting favorable treatment, that would be sort of the better bet. Okay, so the important question is, what can we learn from this? And there's a lot of law around what constitutes fair lending, but the kind of basic question that US legislation like the Fair Housing Act and the Equal Credit Opportunity Act asks is, does Wells Fargo use the same lending standards across groups? So in other words, do you have to be more creditworthy to get a loan if you're a minority applicant? And at this conference, I probably don't have to point out that there's no one kind of like consensus definition of what discrimination is, but this particular definition is very important kind of legally, and it also has a long history in the economics literature. And so it's kind of a worthwhile question to understand, and it's what I'm going to focus on today. But I just sort of, this is already a long talk, and I'm going to use the word discrimination a lot of times, so just know that I'm using it as a shorthand for this particular kind of meaning. And I'm going to make this more mathematically precise in a moment as well. Okay, so if that's our goal, then the obvious answer is that we probably can't hope to learn too much just by comparing the lending rates, for the simple reason that there are a lot of other factors that enter into this decision that we haven't adjusted for. And so there are other reasons why this might happen, even if Wells Fargo is not discriminating. And even so, looking at this difference is a very standard thing to do. It's kind of the jumping off point for most sort of more sophisticated statistical analyses of discrimination. And it's such a natural thing to do that people don't always give it a name, but when they do give it a name, they often call it the benchmark test, since it benchmarks the approval rate, the lending rate for the majority group against the minority group. Okay, what's going on? Okay, so Gary Becker, who kind of founded the study of discrimination in economics, was, to the best of my knowledge, one of the first people to point out that the benchmark test is not a very reliable test of discrimination. So in his Nobel Prize acceptance speech in 1992, he said that recent studies on whether banks discriminate in their mortgage lending compare the likelihood of getting a loan for minority and white applicants. Unfortunately, these studies do not use the correct procedure. So what's sort of interesting is, in addition to this criticism, Becker also kind of came up with a solution. So he said that if banks discriminate against minority applicants, they should earn greater profits on loans actually made to them than to majority applicants. This was kind of confusing to me the first time I heard it, but the intuition is pretty straightforward. So if we imagine that the repayment rate for minority borrowers were, say, 95%, but for majority borrowers it were only 30%, then that would be a very strong signal that the bank held minority loan applicants to like a higher lending standard, meaning that only exceptionally qualified minority applicants were getting loans. So this alternative test of discrimination has come to be known as Becker's outcome test, since it looks at the outcomes of decisions rather than the decisions themselves. Okay, so in part because it's so simple, the outcome test gets used all the time, both kind of in and out of academia. So it gets used for slightly navel-gazy purposes, like looking at whether articles are held to different standards depending on the ideology of the authors of the article and the editors of a journal. So here, the author's hypothesis was that same ideology articles would have fewer citations, kind of in parallel to the group receiving favorable treatment, paying their loans back less often in Becker's lending model. It's also been used, for instance, to study discrimination in medical decision making. So this is an excerpt from a study that looked at COVID test positivity rates that concludes that minority patients were only tested when they were sicker because their tests came back positive more often. And finally, I think kind of the most common application of the outcome test, especially in policy, and the one that I'm going to talk a little bit more about at the end, is that it's frequently used to try to detect discrimination policing. So here, this is an excerpt from a news article, and the outcome is recovering contraband, so sort of weapons or drugs, during a traffic stop, and the lower repayment rate here is sort of simple, it's going to be analogous to recovering less contraband. Okay, so let's say that we've all now read Becker's Economics of Discrimination, and we've come back to audit Fels-Wargo. And they give us access to their loan data, and we perform the outcome test by calculating the repayment rate for both groups. So we find that the repayment rate for majority borrowers is lower than for minority borrowers. So this is exactly what the outcome test said we should look for if minority borrowers are being held to a higher standard. So the question is this compelling statistical evidence of discrimination? Okay, so to answer that, I'm going to spend just a second being a little bit more specific about what the kind of mathematical model is here. So the idea is that somebody walks into the bank and talks to a loan officer and fills out an application for a loan. So let's call all of that information X. And importantly, since we want to allow for the possibility that the loan officer is discriminating, that information is going to include what group that person belongs to. The bank is then going to use this information to estimate the loan applicant's probability of repaying their loan. We don't need this assumption, but just to keep things simple for this talk, we're going to assume that the bank does this sort of perfectly. And then the bank has to make a decision about whether or not to make the loan. So again, we don't kind of need this, but for simplicity, we're going to assume that the bank is rational in the sense that there's some threshold, TG, where the bank lends to everyone whose probability of repayment is above that threshold and doesn't lend to anyone whose probability of repayment is below that threshold. But the way that discrimination kind of enters this setup is we're going to imagine that the threshold might depend on whether the applicant is a member of the majority group or the minority group. Okay, and finally, if the applicant gets a loan, they either repay it or they don't. So the kind of key statistical challenge here is that we're going to assume that we can only observe the very end of this process, right? So we'll assume that we know whether the applicant got a loan, and we'll assume that we know whether that loan got repaid, but we're not going to assume that we know any of the information that went into making the lending decision. And so the question that we're going to try to answer using that information is the threshold for the majority group less than the threshold for the minority group? Okay, so again, even the outcome test is not compelling evidence of discrimination in this sense. So it's entirely possible that Fels-Wargo is lending in a completely non-discriminatory way. So for instance, a common pattern that you see sometimes is that like discrimination in an earlier stage means that only more than typically qualified minority individuals are even kind of making it to the point of applying for loans. And so that means that the risk distribution, so the distribution of how likely people are to repay their loans, is going to be right-shifted for minority applicants. They're going to be sort of more than typically credit-worthy. And so that's what's shown in this plot over here. And the key point is that even though Fels-Wargo has the same lending threshold in this example for everyone who comes in the door, regardless of what group they belong to, because even among people who get loans, the typical blue minority applicant is more creditworthy, we're going to see differences in the repayment rate that to the outcome test are going to look like discrimination. And you could even imagine modifying this example. Maybe I'll be able to modify it. Uh-oh. Hang on. Um, Oh, okay, great. So you can even imagine modifying this example to lower the threshold for the blue group so that now the outcome test is actually telling us that lenders favor the red group applicants when in fact exactly the opposite is happening. So this phenomenon is known as inframarginality, since the repayment rate is a function both of sort of the marginal lending threshold that the bank is using to make its decisions, as well as the whole distribution of risk. And unfortunately, this is not just a theoretical possibility. It comes up quite a lot in practice, as we'll see a little later in the talk. Why is this not working anymore? Okay, so inframarginality is a very well-known problem with outcome tests. And in the kind of 30-ish years since Becker's Nobel lecture, there's been a lot of work trying to figure out how to get around this issue. So for instance, there's been work that tries to get around it by looking at kind of equilibria, where we model the actors involved as a particular kind of rational economic agent. There's been a variety of work that tries to leverage differences between individual decision makers and what groups the decision makers themselves belong to. And there's also been work using modeling with parametric assumptions that help to identify the risk distributions and lending thresholds. And as you can imagine from the fact that there are so many solutions that maybe none of them have really been super satisfying. Okay, so what do we do? So an important kind of piece of context here is that people, and especially policymakers, do run outcome tests all the time. Sometimes because it's all they kind of know how to run, but sometimes because for data reasons, it's like literally all that you can do. So it'd be very useful if we could recover something kind of more statistically solid from the outcome test. So to make some progress on the problem, it's useful to revisit our counterexample from before. So in particular, I want to look at the lending and the repayment rates. So remember, we said that Fels-Wargo was lending to 64% of majority applicants. 64% of majority applicants were repaying their loans, whereas 71% of minority applicants were. And that exactly mapped onto this setup where Fels-Wargo is using a uniform threshold to make its lending decisions. So what about the lending rate? Well, we said that it was 91% versus 87% for minority applicants. And that doesn't match our data at all. Right, so in particular, we said that the repayment rate for majority borrowers was lower and the lending rate was higher. But in our counterexample, both the lending rate and the repayment rate are higher for the minority group. So this kind of suggests an intuition, which is that if there's not discrimination, the group with the higher lending rate should also have the higher repayment rate. So in other words, it shouldn't be possible for the outcome test to point toward discrimination, which it does because the repayment rate is lower for the majority borrowers, and for the benchmark test to point toward discrimination, which it does because the lending rate is higher for majority borrowers, unless there's discrimination. So the robust outcome test is just kind of a formalization of this intuition. So in particular, let's imagine that we see a lower repayment rate for the majority group than the minority group. So this is the outcome test saying that there is discrimination against the minority group. And let's also imagine we see a higher lending rate. So this is the benchmark test saying that there is discrimination against the minority group. So then, because both of these tests agree, we're going to conclude that there's discrimination against the minority group, right? So that is, we're going to conclude that the lending threshold for minority loan applicants was higher than for majority loan applicants. Okay, but here's the catch. If both the lending rate and the repayment rate are higher, then the test is going to be inconclusive. So it could be that what we're seeing is the result of discrimination. It could be that what we're seeing is also the result of a uniform decision policy for both groups and just differences in risk distributions. We're just not going to be able to say on this basis. Okay, so here's the key questions. We saw that comparing lending rates in the benchmark test and comparing outcome rates in the outcome test both can kind of lead us astray. So can the robust outcome test also be wrong? So the answer is yes. So here's an example where the robust outcome test would tell you that there's discrimination against the minority group because the lending rate is higher for the majority group, but the repayment rate is lower. But in fact, though, there is a uniform lending threshold here. Okay, so to understand what went wrong, the right thing to look at turns out to be the proportion of people in a given group as a function of risk. So in our first example, where we got the idea for the robust outcome test, the densities looked like this. They had similar variances, and you can see that they're crossing exactly one time. And in particular, if we look at the proportion of people who belong to the majority group as a function of risk, we see that it's a monotonically decreasing function. Right? So this is exactly what we should see here. Most high-risk borrowers come from the majority group, and as the probability of repayment increases, we see larger and larger proportion of people coming from the minority group. In contrast, in the example where the robust outcome test failed, things looked very different. So the two risk distributions had very different variances, and they crossed 2 times, as you can see there. In particular, this means that the problem of estimating whether someone will default is much easier for the minority group than for the majority group. So for most people in the majority group, figuring out whether or not they'll repay their loan is more or less a coin toss, right? They have basically a 50% probability of repaying. But for lots of people in the minority group, we know for sure either they're not going to repay or they will repay. Okay. So if we look at the proportion of people belonging to the majority group as a function of risk here, we also see something very different, right? So now this function is very non-monotonic. It starts very low, and it goes up, and then it ends very low again. And that's because the minority group risk distribution has a lot of mass near 0 and 1, whereas the mass for the majority group risk distribution is concentrated near 1/2. Okay. So these two different worlds, right? We have the first world where the probability of belonging to a particular group conditional on risk was monotonic. We also have the second world where the probability was non-monotonic. And in the monotonic world, the robust outcome test seemed to work. And in the non-monotonic world, it failed. Okay, so here's a theorem. So the theorem is that the probability, suppose that the probability of belonging to the majority group as a function of risk is monotone in R, and that the outcome test says that there's discrimination against the minority group, and the benchmark test says that there's discrimination against the minority group, then it really is mathematically guaranteed that what's going on is not something funny with the risk distributions, but it's really that the lending threshold for the majority group was lower than for the minority group. Okay, so there are a few assumptions in the theorem that I just stated. Most of them can actually be relaxed quite a bit, and I can talk about that more at the end if people are interested. But the one that you should really worry about the most is the monotonicity assumption. So let's talk about that for a few minutes. So what does this monotonicity assumption mean? So it is an assumption, as we've seen. It doesn't have to hold. But at an informal level, we roughly expect 2 risk distributions to satisfy our monotonicity assumption when we don't have more information for one group than for the other. So we see this in our risk distributions from the fact that in our top example here, the variances are the same, whereas in our bottom example, the variances are very different. I do want to point out before moving on that this is really sort of a sufficient rather than a necessary condition. So you can also have distributions with very different variances that also have different means and satisfy this monotonicity condition. But the point is just that the intuition that we should be seeing this a lot in practice is coming from the fact that we should expect to see monotonicity roughly when our prediction problem is sort of not harder for one group than the other. So in particular, if you see that the problem is much harder for one group than the other, I think it's reasonable to wonder whether decision makers are maybe ignoring important features to mask discriminatory intent. So redlining, for instance, is an example of this in lending, where lenders kind of ignore key individual features of creditworthiness so that they can justify denying loans to minority individuals. Okay, so one nice thing is that many familiar parametric models used to model these kinds of risk distributions satisfy the monotonicity property. So I'm just going to go through them super quickly. So beta distributions with the same variance or that cross once, gamma distributions, normal distributions with the same variance, binomial distributions with the same count. So again, intuitively, this is akin to saying that you have the same amount of information for both groups, logistic distributions with the same scale, and in fact, any kind of monotonically monotone transformation of a pair of distributions with this property will still have this property. So, you know, log normal, logit normal, log gamma, whatever you want, kind of so on and so forth. Okay, so that's a pretty broad class of models to work with. Can I take your question at the end? But even more importantly, in practice, it turns out to be an assumption that empirically holds, seems to hold in a lot of domains. So this is an example of risk distributions from real lending data, not from Fels-Wargo. And the x-axis here is showing overall risk deciles for the distribution. The y-axis is showing the probability that an individual in that risk bucket belongs to either the majority or the minority group. And so the red line is comparing black and white individuals, and the blue line is comparing Hispanic and white individuals. And in particular, you can see that we generally see the monotonicity property holding, although when we compare Hispanic and white individuals, it's really kind of flat, and it's not actually truly monotonic, right? We also see monotonicity in criminal justice. So this is looking at risk distributions from New York City stop and frisk. So risk is sort of the ex-ante probability of somebody possessing contraband. This is another example of criminal justice using Compass data from Broward County, Florida. We also see this in admissions. So for instance, this is showing monotonicity for law school applicants. Again, real data where the outcome is whether or not they pass the bar, and we're calculating this probability using their kind of admissions dossier, like their LSAT score and things like that. And I should say that in all of these examples, monotonicity is really only holding approximately, right? It's not literally true. And we shouldn't expect more than that in any real world data set, in the same way that we never expect two things to be literally equal. So given that the data sets we'd like to apply the robust outcome test to are, by and large, real world data sets that are guaranteed to not literally be monotonic, it's useful to try to understand how robust our robust outcome test actually is. So the natural way to do this is with our empirical risk distributions. So we can just take those risk distributions as ground truth, and then we can calculate what the robust outcome test would tell us in all sorts of discriminatory and non-discriminatory scenarios. And so to study this, let's start by looking at our lending data. So here, the X and Y axes are showing simulated decision thresholds for black and white loan applicants in our lending data. And so the dashed line is showing scenarios where the decision maker is using the same threshold for both groups. So the area above the dashed line shows scenarios where the bank has a lower lending threshold for white borrowers, which is what the little X's show, sort of like true discrimination against black loan applicants. And the area below the dashed line with the dots is showing scenarios where the bank has a lower threshold for black borrowers. So kind of true discrimination against white borrowers. And finally, the colors are going to show the result of the outcome test. So blue is showing places where the outcome test would find discrimination against black individuals. Yellow is the sort of scenarios where it's inconclusive. Sorry, that's a little hard to read. I didn't realize it'd be so washed out. And red is where it's favoring black borrowers. So what we're seeing is that across scenarios, even though we don't have perfect monotonicity, the robust outcome test is essentially always correct anyway. So when it says that there's discrimination against a group, that is almost always the correct inference, though as expected, sometimes it gives us an inconclusive result. We can also compare the robust outcome test to Becker's standard outcome test, and what we find is that the standard outcome test is kind of wrong all over the place. So there are lots of scenarios where it would suggest discrimination against a group that in reality received preferential treatment. And in fact, we see basically the same pattern across all of our real-world data sets. So despite monotonicity being only approximately true, the robust outcome test is essentially always a reliable signal of discrimination, and the standard outcome test is often misleading. Okay, so that's a lot of theoretical arguments about the robust outcome test, but what happens in practice? So one possibility that I haven't really sort of owned up to so far is that maybe it's like correct, but it's actually useless. So maybe whenever you do this in practice, you know, it's always inconclusive and you never learn anything worthwhile. So to test this, we're going to analyze whether law enforcement agencies are applying uniform evidentiary standards to people of different races when they're deciding to search people for contraband. So this is probably the most common application kind of in the real world of Becker's standard outcome test. And so the American criminal justice system is very, very fragmented, and state and local law enforcement agencies vary very widely in the kinds of administrative data that they collect. Integrated policing data is very hard to come by, but California in particular has something called the Racial Identity and Profiling Act, or RIPA. And RIPA mandates that California law enforcement agencies record detailed information about all of the stops that they make in a standardized way across the state. So the law was passed in 2015, and initially it only applied to the largest police departments, so like LAPD, SFPD, things like that. But in 2022, it kind of came into full effect, meaning that every law enforcement agency in the state had to start reporting their data through RIPA in this way. And so as you can imagine, the RIPA data from 2022 are quite rich. They cover more than 4 million police stops across over 500 law enforcement agencies. So we're going to look at kind of the 60-ish largest And to apply the robust outcome test to the RIPA data, we're going to have to kind of reorient ourselves slightly compared to the lending example. So the analog of the bank giving someone a loan is now going to be the officer deciding to search someone. So I'll call how often that happens the decision rate. And the analog of that person repaying their loan is the officer finding contraband like weapons or drugs. So I'm going to call that the outcome rate. And let's start by imagining that we just applied Becker's standard outcome test, which amounts to comparing the outcome rates for different groups. So the important thing to keep in mind here is that because, unlike getting a loan, getting searched for contraband is generally undesirable, discrimination against black individuals means that the threshold for searching them is lower, not higher. Right? So in particular, moving to the left on this plot means that the outcome rate of black individuals is lower than white individuals, which again, according to the standard outcome test, is evidence of discrimination against black individuals. Well, moving to the right means that the outcome rate for black individuals is higher, which again, according to the standard outcome test, is evidence of discrimination against white pedestrians and motorists. So this is a little bit weird. So using the standard outcome test, we're basically finding that about 2/3 of departments are discriminating against black individuals, while the other third are discriminating against white individuals, sometimes like quite dramatically. And this is not like logically or physically impossible, but it definitely contradicts a lot of other evidence, including sort of sophisticated analyses of some of the specific departments that are on the right-hand side here. And so as a result, I think when most people see this, their takeaway is not that a third of California law enforcement agencies discriminated against white pedestrians and motorists, but rather that the outcome test really doesn't have face validity as a measure of discrimination. And at a higher level, this is really important because if you want to use the outcome test in policy or in the courts, because it points toward discrimination in lots of cases that are not super plausible, it makes it very easy to dismiss in cases where it's probably correct. So if we perform the robust outcome test, however, we kind of see what's going on with a lot of the weirdness. So in particular, in many of the places where the black outcome rate is lower, which suggests discrimination against black individuals according to the standard outcome test, the decision rate is also higher, right? So the robust outcome test is still saying that there's discrimination against black individuals. On the other hand, in almost all of the places where the white outcome rate is lower, which again seems sort of anomalous, the white decision rate is also lower, so the robust outcome test is actually inconclusive, right? So in other words, the robust outcome test, sorry, 1 minute, okay, cool. The robust outcome test is telling us that many or maybe even all of the suspected cases where Becker's standard outcome test suggests discrimination against white people, there's not actually enough statistical evidence to make that conclusion, at least on this basis. So the robust outcome test kind of confirms the standard outcome test in places where other kinds of evidence also suggest that the standard outcome test is correct. And in places where the standard outcome test is sort of like anomalous, the robust outcome test indicates that maybe there isn't actually enough statistical evidence to be using the standard outcome test. Right, so to briefly summarize, the point is that the robust outcome test really does have face validity as a measure of discrimination, and then when it does find discrimination, that information is actually actionable in a way that's sort of simply untrue of the standard outcome test. Okay, so that is it. Thank you very much for your attention. I'm happy to take any questions if there's time.